Welcome to today's Explainer. Have you ever actually stopped to think about the systems running your digital life? Think about your routine for a second. You swipe through a social feed, stream a video, tap a button, and a ride magically routes to your exact location, or you ask an AI a question and get a human-like response instantly. How do all these completely different apps actually work under the hood? Well, the secret is that they all rely on an invisible digital backbone. They're constantly talking to each other using something called an API. Today, we're going to demystify this invisible backbone, taking the complex web of modern software and making it crystal clear. Okay, let's dive into this. Here is our roadmap for today. First, we'll define what an API is. Second, we'll look at the front end and back end. Third, we'll break down how data actually communicates. Fourth, we'll look at real-world API applications. And finally, we'll cover security and modern architecture. All right, part one. What exactly is an API? Before we even define the acronym, we've got to ask the ultimate foundational question. How on earth does the front end, the pretty buttons and menus you click on, actually talk to the back end, those heavy-duty servers doing all the hard work? They have to have a specific mechanism to connect. That mechanism is the API. It stands for Application Programming Interface. Now, I know that sounds super technical and maybe a little intimidating, but actually, scratch that, it's way simpler than it sounds. At its absolute core, an API is really just a communication window between two systems. It is a formalized, structured way for two totally different pieces of software to talk to each other, swap information, and ask each other for favors. It's essentially the ultimate digital translator. Moving on to part two, let's look closer at those two main players, the front end and the back end. To picture this, think of any modern website or app as a restaurant. The front end is the dining room, and you are the guest. You interact with all the visual stuff. You look at the menu, admire the decor, click buttons, fill out forms. But when you want food, you don't just kick the kitchen doors open and start cooking the meal yourself, right? The actual heavy lifting happens in the back end. That is our busy kitchen. It holds the servers, the secure databases with your account info, and all the complex business logic that processes your request. The guest needs the kitchen, and the kitchen needs the guest. And this brilliantly illustrates exactly where the API comes in. The API is our waiter. Think about it. As the guest, you look at the menu and give your order to the waiter. The waiter takes that specific request, walks back into the chaotic kitchen, hands it to the chef, waits for the meal to be prepared, and then carries your hot food right back out to your table. You didn't need to know how the stove worked, and the chef didn't need to know what you were wearing. The waiter, our API, handled the whole shebang perfectly. So, part three, how does that data actually communicate? Let's walk through an action we all do every single day. Clicking a login button. It happens in 4 super quick linear steps. Step 1, your browser sends an HTTP request. That's you handing the waiter your order. Step 2, the web server, or waiter, receives it and carries it to the back-end kitchen to verify your username and password in the database. Step 3, the back-end responds. If everything matches, it sends back a success message. Finally, step 4, the front end updates your screen, instantly logging you in and showing your personalized dashboard. Now, you might be wondering, how does our digital waiter know exactly what kind of action to take? Well, on the web, most APIs use specific HTTP methods. Think of these as the specific instructions jotted down on a restaurant order ticket. A GET request is simply asking to retrieve data, like asking for a glass of water. POST is when you want to add new data, like submitting a brand new order to the kitchen. PUT is used to modify existing data, maybe changing your side from fries to a salad. And delete is, well, exactly what it sounds like, canceling the order completely. These 4 commands literally run almost every interaction you have online. And what language does this digital waiter read? Today, pretty much all web APIs transfer data using something called JSON, JavaScript Object Notation. It's incredibly lightweight and simple. It uses pairs of data, linking the word username to Tom and password to 123. It is the universal standard handwriting for our order tickets because it is incredibly easy for both humans to read and for machines to instantly parse. All right, part 4, let's look at some real-world API applications. Let's zoom out a bit. Companies rely on APIs constantly, so they don't have to reinvent the wheel. If a real estate website wants to show you a map, they don't launch their own satellites, right? They just call the Google Maps API. When you swipe a credit card online, the store doesn't process the complex banking logic. They use a payment API like Stripe. Want to know if it's going to rain? An app just calls a weather API. And get this, when you use a complex AI chatbot, you're essentially just sending a massive post request to an open AI API. The supercomputer heavy lifting is done on their end, and the answer is simply carried back to your screen. You might think creating one of these requires thousands of lines of code, but it is shockingly simple. Using Python and a tiny framework called Flask, you can spin up an API in about 5 lines of code. You just import the tool, name your app, and set a route that returns a simple JSON message. That is it. You've officially hired your very first digital waiter. Finally, Part 5, Security and Modern Architecture. Because APIs are the direct doorway to a company's data, hackers absolutely love targeting them. I mean, why try to break through the heavily fortified front end when you can just trick the waiter into handing you the kitchen keys? Bad actors use tactics like SQL injection, where they slide malicious database commands into a JSON request. They'll attempt token theft to steal active user logins, or they use API flooding, sending millions of fake requests in seconds to completely overwhelm and crash the backend server. So how do we stop this? Well, large companies don't just let anyone talk directly to their back-end kitchen anymore. They place a powerful middleman in front called an API gateway. Think of it as a really intimidating, strict maitre d' standing at the entrance. Before your request even gets to the waiter, the gateway checks your ID for authentication, balances the server load, and aggressively limits the rate of requests to block those flooding attacks dead in their tracks. It ensures the kitchen stays completely insulated and safe. So, what does this all mean for us? The modern websites and apps you interact with every single day are kind of just beautiful empty shells. They are designed to look amazing, sure, but their true purpose is just to wait. The true heart, the real muscle of the modern web, is the API. It's that invisible digital waiter tirelessly running trillions of requests back and forth across the globe every single second. So the next time you seamlessly book a flight, order food, or instantly message a friend across the world, take a moment to ask yourself, what other invisible systems are secretly running my digital life? Thanks for joining me for this explainer. I'll catch you next time.